You know, most farmers spray chemicals on their crops, and it's a real concern for both farmers and environmentalists when those chemicals wind up someplace other than on the target crops. Well, now there's a new way of applying pesticide that makes it stick like glue only to the plants that need it. CNN's Miles O'Brien filed this report.
Spraying chemicals on a crop can be messy and wasteful, with more pesticide going into the ground than onto the plants. Now a new spraying system uses an old principle to make droplets stick to leaves, drawn by an attraction so strong that the spray often defies gravity to jump onto the bottom surfaces of leaves. Developers say the new method gets much better results than the old one.
Conventional spray application of pesticides is a very inefficient process. Quite often there is less than 20% of the material that's dispensed from the nozzle that actually gets on the desired plant target. We've been able to at least double the deposition efficiency.
The key is static electricity. The nozzles give the spray droplets a negative charge. Scientists have known for centuries that when a charged cloud gets close to an electrically neutral object, like a grounded plant, the object takes on the opposite charge. And they've known for even longer that opposite charges attract. That attraction is what makes the spray cling to all sides of the leaves. The Georgia researchers demonstrate the principle with a simple setup of an apple connected to a ground wire and a machine that fires blasts of powder. On the first pass, the particles of powder are not electrically charged. And the apple gets a spot of powder on the side where it hit. The second time around, the powder is given an electrical charge. And the apple winds up with a uniform coating of powder on all sides, showing that the electrical attraction was strong enough to capture powder particles as they sped past. A more elaborate demonstration shows clearly how an uncharged spray of water goes right past a rubber plant. But when a charge is added to the water droplets, they jump onto both sides of the leaves. The process is somewhat similar to the way cars and appliances are currently painted, but there are big differences too.
All of those systems in industry involve much too high a voltage and a level of risk for the operator to put it outdoors in agriculture. And secondly, those systems in industry don't have to penetrate the charged particles down into a deep target zone like a plant canopy.
The Georgia researchers had to come up with new ways to charge the spray for use on plants. While the research continues, the first commercial versions are already in use on farms and in plant nurseries. Greenhouse owner Gip Marchetti has been using the system for 3 years.
It definitely covers better, uses less chemical, and exposes me, the sprayer, and my employees less than any other sprayer that I've ever had. This is about a 4,500 square foot house, and I can spray basically 3 layers in less than 15 minutes. With a conventional sprayer, it would probably take me closer to 2 hours to thoroughly cover everything.
Dr. Law says by reducing waste, the system cuts the amount of chemicals needed by half or better. U.S. farmers use 800 million pounds of pesticide annually, so the electrostatic system has the potential to eliminate 400 million pounds of chemicals entering the environment every year, at a savings to U.S. farmers of $3 billion.